This video is going to take a look at the same exact concept that we looked at before of solving systems, but this time we're going to look at it using a method called substitution. The idea behind substitution is sometimes systems of equations are very difficult to solve by graphing. So brace yourself, some ugly systems might be coming. However, when graphing is not accurate or helpful, for example, if the answer is a fraction, a decimal, larger than 10, if the answer was 72, negative 46, you don't want to graph that. We need a second method that's going to make it much easier, and that method is called substitution. The idea behind substitution is that if we know what one variable equals, we can replace it with that in the other equation to reduce the other equation from two variables down to one. And we'll use parentheses when substituting. For example, we've got this system of equations here where x equals 4 and 2x plus 5y equals 7. We already know that x equals 4. So in the other equation, we can replace the x with what it represents. Replace the x with the 4. So we would have 2 times 4 plus 5y equals negative 7. 2 times 4 is 8, plus 5y equals negative 7. And we can solve this equation for y by subtracting 8 from both sides. And 5y equals negative 15. Divide both sides by 5. And I'm running out of space here, but what we see is y equals negative 3. In other words, we've got the point x4 y equals negative 3 is where these two equations are going to cross. No graph needed. So if I know what one variable equals, we can plug that into the other equation. Now, usually it's a little more involved than that, like these two examples, but the concept here is exactly the same. This first equation says y equals 2x. So wherever I see a y, I can replace it with the 2x, always in parentheses. Because they're equal, we can replace one with the other. So the second equation then becomes 3x plus 2y, but we know y is 2x equals negative 21. And we can simplify 2 times 2x is 4x, so we have 3x plus 4x equals negative 21. Add those together. You've got 3 x's and 4 more x's. That's a total of 7 x's is equal to negative 21. And if we divide both sides by 7, we find out our x value is equal to negative 3. Well, we have x. Now we need to find y. Well, we know what x equals, so we'll plug it back into the other equation. Y is equal to 2 times x, or 2 times negative 3. So y must be equal to negative 6. We know that these two lines are going to cross at the point negative 3, negative 6, without having to go through the work of making both graphs. We did that using a method called substitution. And the problems can become increasingly complex, but the idea is still going to be the same. If we know what one variable equals, like in the second example, we can replace it in the other equation. Here, the second equation tells us that x is equal to 3y minus 7. So we can replace the x in the other equation with 3y minus 7. So we have negative 2 times, always in parentheses, 3y minus 7 plus 4y equals negative 10. Well, we get that negative 2 through the parentheses by distributing. Negative 2 times 3 is negative 6y. Negative 2 times negative 7 is positive 14. Plus 4y equals negative 10. Let's combine our like terms together. Negative 6y and 4y is negative 2y's. plus 14 equals negative 10. We can solve this equation balancing on the equal sign by subtracting 14. And negative 2y equals negative 24. Divide by negative 2. Y is equal to 12. Now that we know what y equals, we'll plug it into the x equals equation to figure out what x equals. X is equal to 3y, 3 times 12, minus 7. Well, 3 times 12 is 36 minus 7. X is equal to 29. Now, we certainly didn't want to graph this one. But because of substitution, we could plug one equation into the other and find out that x is equal to 29, y is equal to 12. We know the solution to both equations. Now, sometimes we're faced with a situation where we don't have an x equals or a y equals. In that case, we might need to solve for a lone variable, get one of the variables completely alone before we can do much with it. So in this case, I notice we've got this positive y here. If I could get that positive y alone, we'd be able to make a substitution. The negative y wouldn't be as nice because that's a negative. We want the regular positive 1y or a regular positive 1x alone. And we can get that in this first equation by adding 4x to both sides. And when we do, we get y equals negative 1 plus 4x. And now that we have y equals this stuff, we can go to the other equation and stick that stuff in there. 2x minus, always in parentheses, negative 1 plus 4x equals 5. Distribute that negative through. 2x plus 1 minus 4x equals 5. Combine like terms. Negative 2x plus 1 equals 5. And now that we're simplified, we're ready to solve. Subtract 1 from both sides. Negative 2x equals 4. Divide both sides by negative 2. And x is equal to negative 2. Now we can find y by plugging that into the y equals equation. Y equals negative 1 plus 4x, or 4 times negative 2. Order of operations says we multiply first. 4 times negative 2 is negative 8. And so y is equal to negative 9. And now we've got the solution to our system of equations. X comma y, negative 2, negative 9 is where these two lines will intersect. Substitution is probably my favorite way to solve because it's so straightforward. It works every time. Sometimes we have some ugly fractions, but usually we can avoid them. But if we can get one variable all alone, y equals stuff or x equals stuff, plug it into the other equation, and you'll be able to solve your system of equation by substitution. Take a look at the homework assignment and try a few on your own. Let me know or let your instructor know if you have any questions. Good luck as you do your work.